Hi, my name is Nuna bin Bidi Jalil, CE200153. I will present our group project, and me and my team members from class Bej20203, Signal and System from section 2, and our lecturer is Dr. Siti Haja Amina binti Ali. And this video project is presented to present our project that was assigned to us to be done. And I will show you our team members. First we have Muhammad Iqbal bin Muhammad Atipi, CE200113. Second we have Nur Iza Farhana binti Alias, DE190167. Third, we have Nurul Shahira binti Hairul Kamal, CE210105, and we have Shahmina binti Ruslan, AE190132, and last we have Amin Nabiha binti Jalil, CE200153. Okay, and next, in the report, we have abstract, introduction, methodology, result and analysis, conclusion, and also reference from this project. So basically, I will explain a little bit of abstract. So abstract is our aim for this project requirement is to provide the outcomes from what we have learned during lecture time. So for the manual calculation are based on our theories of Fourier series, Fourier analysis, and low pass filter theory. Then we have to prove it by using software. Software we have to choose is MATLAB, and we have to utilize MATLAB from our manual calculation result and produce simulation result based on our manual calculation. So for the keywords in this project is MATLAB, low pass filter, Fourier series, Fourier analysis, and also manual calculated simulation result. Next, we have introductions. So in this project requirement, we have to do manual calculation, and after that, we have to prove by using MATLAB software. So actually, we have decided to put a low pass filter in this project, and this is a little bit of explanation on what is low pass filter. So low pass filter is actually filter that lets signal with frequency lower than a certain cut-off frequency to pass while dampening signal with frequencies greater than the cut-off frequency. So all the low pass filter will rated at certain cut-off frequency. Low pass filter allows for passage of low and difficult of high frequency signal. The frequency cut-off for low pass filter will load at 70.7% if source is voltage. And then Fourier series are the most significant things in this project because we used to have to elaborate what is periodic signal. There are types of Fourier that we have five types of Fourier series. So we have Fourier integral, the classic Fourier series, discrete time Fourier transform, and discrete Fourier transform. So Fourier series has each harmonics phase and amplitude can be machined in steady state mode. In Fourier series has each harmonic phase and amplitude can be determined using harmonic analysis. The purpose using the Fourier transform for the harmonic analysis of the induction machine is in steady state regimen. The signal content at a specific frequency is defined as a multiple integral of the current frequency system or mean frequency produced by the generator. The result series is referred to as a Fourier series. It creates a relationship between a time domain function and a frequency domain function.
And good day. My name is Nur Iza Farhana binti Alias. My matric number is DE190167, and I will explain about the methodology. So a low pass filter is a filter that amplifies signals above a cut-off frequency, also referred to as the passband, and attenuate signal below the cut-off frequency known as the stopband. So low pass filter generate gradual variations in output value that make it simpler to see trend and improve the overall signal to noise ratio with little signal loss. So we use the MATLAB to design finite impulse response, FIR based and infinite impulse response, IIR based filters, that two common low pass filter method. So this is a design specification and response of a low pass Casio FIR filter in MATLAB. and this is design specification and response of a low pass Chebyshev type 1 IR filter in MATLAB. So the low pass function in signal processing toolbox in MATLAB is particularly useful to quickly filter signal. So we can use design fit and other algorithm specific Butterfield1 function when more control is required on parameters such as filter type, filter order, and intonation. That's all from me. Thank you.
Assalamualaikum and greetings. My name is Syahmina binti Rislan, metric number AE190132, and I will explain about the various series expansion in the MATLAB software. So first we run the code for the various series in terms of time domain. The n is equal to 5. We obtain this waveform. When n is equal to 10, we can see that the sinusoidal waveform is starting to get closer to the reference signal. And when n is equal to 20, you can see that the sinusoidal waveform is getting really close to the reference signal, which is the square wave. The order of the harmonic is given by the magnitude and frequency of the waveform. Basically, the harmonics are the multiples of the main signal. The first harmonic is the main signal, and as the order of the harmonic gets higher, the signal shown will be closer and closer to the original waveform, which is the square wave. We put the waveform in the frequency domain. Frequency domain display how much the signal exists within a given frequency band containing a range of frequencies. This is the result of the frequency domain when n is equal to 5, and then we change the n to 10 and observe the result, and then we change the n to 20, and finally we get this frequency domain, which is visualized as a spectrum. This is so that we can observe the waveform respectively and understand the difference between having different number of n or different order of harmonics. So from me, thank you.
My name is Nur Shahira binti Harun Kamal with metric number CE210105. So I'm going to present or doing a simulation for our project assignment for task 2 and task 3. For task 2, we are asked to construct a low-pass filter with frequency response characteristic given in the questions. So first of all, we need to set a resistor value, which is, in this case, I'm set resistor value as 20 kilo ohm. For frequency, 50 kilohertz. For cut-off frequency, since it needed to be 4 times than the actual frequency here, therefore the cut-off frequency will be 200 kilohertz, as the frequency are multiplied by 4. and the fs here is sampling frequency are given in ratio of 10 by 10 multiplied by cutoff frequency. The sampling frequency or sampling rate is the average number of samples that are obtained in 1 second. So in the question or instruction, we are given the formula of cutoff frequency. In order to find the RC, we need to play with the formula and change it RC as the main subject and FC is the denominator here. So therefore we get RC equals to 1 over 2 pi FC. So for the impulse response, which is H, equals to 1 over 1 J2 pi FSRC. And figure 1 is the output, the name of the output, and the plot will be the sampling frequency and the Fs of H, which is the impulse response. Fs is in MATLAB is known as the returns the absolute value of each element, which is the element in this case is impulse response. And yeah, so we simulate the coding. So as we click the run button, so this is the output, and as it can be seen, it is same as the characteristic curve as given in the instruction. So next one is for the task 3. So as for task 3, we are asked to analyze the output of the filter both in time domain and frequency domain. So here is the coding in order to analyze the output of the filter, and one is time domain, okay, and second one is frequency domain. So we run the coding. So as the result, this is the output, filter in time domain, and in figure 2 is the output that are being filtered in frequency domain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Iqbal bin Mama ATP. My metric number is CE200113. For my part is make a calculation and reference. For the calculation, the Fourier series is a method that can be used to solve the partial differential equation. The Fourier series allows us to use techniques that we have used before to solve the ordinary differential equation. Like the Fourier transform, we end up with a solution that represents the function in quotients and signs, but it is easier than to compute. This step will show that for the same equation with similar boundary conditions to compare the two methods. There are many partial differential equations that represent many dynamic systems and two techniques that can be applied for all with varying steps required to come up with a solution. And here is my reference for this project. Thank you.